All right, welcome to session 2. Topic of this session is the economic realities of climate change policy. We have 3 outstanding panel members. David Tuerck, the first gentleman to my left, is professor and chairman of the economics department at Suffolk University. He is also the executive director of the Beacon Hill Institute on Public Policy Research. He's going to be presenting on state efforts to promote renewable energy and the costs of the same. Second speaker will be Robert Mendelsohn. Professor Mendelsohn is professor of economics and professor of management at Yale University. He's the author of over 100 peer-reviewed articles. He's edited 6 books. He's one of the world's leading experts on the economic consequences of climate change. And the third speaker is David Schnarr, PhD. David is a scientist and an attorney in EPA's Office of Enforcement and Compliance Assurance. He has spent over 40 years in federal and private sector roles consulting on and litigating local, state, and federal and international environmental regulations. So please welcome our first speaker, Dr. David Tuerck.
Hello, everybody. I'm most pleased to be here and honored to be invited. I decided I was going to take an easier path than I did the last couple of times I appeared at this conference. On one occasion, I decided that I would take on Waxman-Markey, which turned out not to be so difficult after all. But it was an ambitious exercise because we had to get under the skin of the Nordhaus model and re-simulate it for Waxman-Markey, which then produced the results that I was able to show. And then last year, I was even more audacious because I recommended the abolition of all energy subsidies, including subsidies to fossil fuels, which proved to be contentious. Why is this? Now I'm going to be contentious to this extent. I want to defend modeling, not just because that's how I make my living, but I think that modeling does a great service. If we didn't have these climate change models, we wouldn't know how to recalibrate them so we could get to the truth. Now the problem with economic models is that we're laying those speculative models on top of the speculative climate change models, and that can lead to even more speculation. Nevertheless, I'm going to talk about some models here, which I plan to defend. And this is despite the tarnished reputation in my profession, where 3 notable economists have returned to academe because they predicted that unemployment rate would be down to 8% after an $800 billion stimulus. Academe being where economists go so they don't have to be accountable for what they say, which is, of course, why I'm there. Now, let me see. I have to realize I have to turn to see this. So I want to key off on the idea that the states are succeeding in wasting resources that the federal government so far proves reluctant to waste. And I use this famous quote from Barack Obama to set the stage for what I'm about to say. I imagine Obama wishes he could take this one back, but nevertheless it does reflect much of the ideological thrust behind climate change legislation. And we know that cap and trade is dead, at least until we get a Democratic House back again. So it's not going to happen at the federal level. It is, of course, unless it comes through the EPA back door, which seems to be underway. Moving back to the states, let me just mention that every state has some kind of climate change legislation in effect. One thing that's popular are public benefit funds, which are surcharges on electric consumption to subsidize green energy. We have renewable portfolio standards in 38 states by our count. Net metering is where if you produce your own electricity, you sell it back into the grid. And every state has some combination, as I said, of incentives to encourage use of renewable energy. And we have been in the business lately of looking at various states for the economic impacts of this, particularly, as you might expect, Massachusetts, where I happen to be. Now, here's the thing. I have a colleague who's written much of our stuff on this issue who has argued in print that if we're going to do anything, we ought to have a national carbon tax. I don't agree with him on that, but I understand his logic. Attempting to do this through cap and trade or through hodgepodge of regulatory measures and all this is highly inefficient. If we insist on doing something and we think it even despite the fact that the United States produces only a minority of the CO2 emissions, then a carbon tax at the national level is the only thing that makes any sense. I would agree with that. What doesn't make any sense are efforts undertaken at the state level. Because even if California, say, were to reduce its emissions by 83%, what would happen is everything in California would just finish moving to Texas. And we'd have to, we'd use it, I guess. Capital is mobile across state lines, to say nothing across national lines. So these state efforts be wasteful from the point of view of the leaders of the state who are charged with bringing about economic well-being to the states that they lead. So it's an interesting discussion in psychology why states insist on going down this path, especially as I hope to convince you as we go through these slides. Now, a quick look at what it costs to produce energy by different sources. You will see there that that natural gas, combined cycle, so-called natural gas, is I guess the cheapest on that list. And then if you have carbon sequestration combined with it, raises the price a little bit. Let me see, offshore wind is by far the most expensive, which is source of another slide, subject of another slide of mine. And we have somewhere on there, we have hydro, the bottom, which seems to be fairly reasonably priced. And I will return to that subject. And then you see the fraction of power that's coming from these various sources right now, all of which tells us that we're not anytime soon going to be getting power in any realistic sense from, to any large extent, from non-fossil fuel sources. Now, turning to Massachusetts, the interesting thing about hydro is that it seems to me to be a highly green source of energy. I know that there are arguments that it has environmental issues connected with it, but the hypocrisy behind the state green energy movement is illustrated by the fact that hydro is a no-no in terms of meeting green energy standards. In Massachusetts, our renewable portfolio standard allows only small hydro plants under 25 megawatts, which are not going to happen because they're too small. Washington State gets 83% of its power from hydro, but Washington State has practically excluded hydro from the satisfaction of its green energy goals, and most state RPSs exclude large-scale hydro as an acceptable form of getting green energy. This presumably because the water cascading over the rocks is going to send emissions into the air. Who knows what it's driving? Well, we know what's driving that is there's no sex appeal there. The sex appeal is windmills, as we'll see in a moment. Now, I have a couple of slides which I tend to pit the geeks against the gougers. I'm going to volunteer to be the geek here. That's not a problem for you, I'm sure. And then I'm going to talk about the gougers briefly. Geeks like me like to drum away on the importance of cost-benefit analysis. And that bores most people. In fact, it offends some conservatives because it suggests that you can do such a thing as measure the social costs of something and compare them to the social benefits. Yet, I think that cost-benefit analysis is highly useful. In fact, if anybody had paid attention to our cost-benefit analysis of the Nantucket Wind Farm project, the project would never have happened, and I'll return to that. But I wish to defend cost-benefit analysis, especially when the results are as dramatic as they were in the case of our Cape Wind study. And I would like to defend it in part because it takes our attention away from phony goals. It's a legitimate goal to want to adopt projects for which the net social benefits are positive. It's a phony goal to want to adopt projects that produce a certain kind of job. The purpose of economic activity is not to produce jobs. The purpose of economic activity is to get as much production as possible with as few jobs as possible, thus explaining all the progress of civilization over the last few hundred years. So I like cost-benefit analysis on those ideological as well as I'm going to suggest practical grounds as well. So we did quite a bit of work on the Cape Wind project. The benefits that we measured in terms of the value of the fossil fuel that would be saved. I won't go belabor this very long, but I want you to get the impression, as I believe, that we were quite thorough in our attempts to get everything in there. We looked at the value of reducing the capacity of other kinds of production other than wind, health benefits, energy independence. We even had something for reduced CO2 emissions. And then we looked at the cost in terms of implementation, installation of the facility. It's expensive to build wind power out in the ocean, as you could see from an earlier slide. And we looked at grid accommodation and so forth. So let me just backtrack very quickly, take a look again at the slide where I have the two kinds of wind, the onshore and the offshore. I hope it's there. Did I leave it off? Yes, there it is. You see the dramatic difference in cost. And now we go to what the geeks in my shop, including me, found as a result of a cost-benefit analysis of this project. It turned out that the social costs exceeded the social benefits in levelized terms by $1 billion. Absolutely nobody paid any attention to this. The federal government agency that was responsible for this project pretended to do a cost-benefit analysis, which it wasn't, and all this was just a way of keeping a lot of graduate students usefully employed as far as the public impact was concerned. We also found that the developer was going to get a healthy subsidy whose present value was about $1 billion. We now find that that's much lower than the subsidy they're going to have to get to make this commercially viable. And we found that there would have been an appropriate subsidy, but the actual subsidy would have been $800-some million higher than what they should have been getting. And we allowed for the fact that there are benefits from reducing fossil fuel production, and we counted the benefits, and we said a subsidy would be okay, but we can't afford, it doesn't make any sense to subsidize this project to the level it would need to be subsidized for it to go forward. Yet, despite this overwhelming evidence against this project in terms of social costs and social benefits, it was approved first by the head of the Interior Department, who came and toured Nantucket Sound wearing a cowboy hat to show sympathy for the rights of Indians who were concerned about the disruption of their religious rights. And this was, of course, there's a done deal from the beginning because Obama is a wind farm fan, and he has his colleague, DeVal Patrick, in the governorship of the state. He, too, is. So this was a done deal. Why did this, I'm sorry, did I do something wrong here? No, here we go. Now, the interesting thing is that our major electric power provider in Massachusetts, National Grid, has agreed, and then I signed a contract to buy half of the Cape Wind power for the next, I think it's 20 years. Why would they do this? That's the question. Well, first of all, pressure from the state. Everybody, these huge utilities are political animals, and they knew where their bread was buttered. And then the state provided a Green Communities Act to nudge them along when the state is requiring long-term contracts for renewable power, and threw in a bonus just to make sure that National Grid would sign on. And the political economic explanation is that the higher rates would be mostly felt by industries whose have a less political clout than they would have to have in order to make a difference. So here's the arithmetic. I won't belabor this, but the National Grid is going to buy this power at 18.7 cents per kilowatt hour plus a 4% bonus. It's going to get a 4% bonus to pay this price. Of course, it's all going to get passed on to the consumer. To get the impact on the price that the consumer pays, and I'm running out of time so fast here, to get the impact on the price the consumer pays, we could start with 18.7 cents, add the 4% bonus, and then subtract the wholesale electric cost, which is 5.6 cents per kilowatt hour, subtract the price of the renewable energy credits, and we end up with a 12-cent per kilowatt hour extra charge. I think I'm going to, in practical terms, wrap up around the Cape Wind example, or maybe I can do a few more things depending on whether I get shot at down here. We can do some calculations and figure out what this is going to cost. The political strategy here is to say, well, it's only going to cost households a few dollars a month, and the residential consumer, correct, will pay only a few dollars a month. The problem is that the residential consumer doesn't use the amount of power that industrial users use. And now that the industrial manufacturers in Massachusetts have awakened to this, they're suing over this thing because they've figured out what it's going to cost their members. And so jumping over all these slides, which we will post on our website and you can get through Heartland, you can take an example of a firm that uses 45 million kilowatt hours a year. And they're going to end up paying 0.39 cents per kilowatt hour for electricity as a result of this deal, and that's going to cost them $175,000 per year more to get power. Now, this has gotten the attention of manufacturers in Massachusetts who are, again, as I said, suing and indeed may be able to stop this project in its tracks. At least they tell me they're optimistic. And this tells you about something about cost per commercial user, cost per industrial user. Now, NSTAR, the other big utility in the state, has figured out a way to get renewable energy to satisfy the state requirements, and it's doing it at about half the price that a national grid is paying. Why? Because NSTAR is not using wind power that comes from an ocean platform. Okay? This project is there as a trophy for Deval Patrick and is now departed Secretary of Environmental Affairs, and as a reward to the developer Jim Gordon for his many years of perseverance on this project. It is not a good way for the state to subsidize renewable energy, given that it doesn't make any sense for the state to be subsidizing renewable energy in the first place. If you insist on this sort of thing, then you should do what NSTAR did, and that's seek more economical sources. And now I have to quit halfway through. This shows you, again, how college professors are completely undisciplined when it comes to preparing presentations. But I can't. I have a minute or two. So let me then skip. We looked at Massachusetts mandates, and here the costs of these mandates. We were able to look at, I think we said 11 of the 25. And we have, we've listed there, and this slideshow will be available to you. You can go back and spend hours and hours with it. You see something about, well, the bottom line is levelized, in terms of levelized costs, $9.8 billion in new electric rates over a 10-year period. That's the present value of these Massachusetts mandates. And that's not talking about the Cape Wind piece. We've done a lot of work on renewable portfolio standards. And we've looked at the economic costs and benefits of those. And I'm going to skip, and I'm going to get to the chart, which shows you where we've done, and this is actually a good place to wrap up. The top RPS standard for each state. Each state has a standard to which it is aiming to get. So Colorado, for example, wants to have 30% of its power provided by renewable sources at some point. And what we did is we said, well, once this is fully implemented, how much will this raise the cost of electricity for the state? And that is in the, actually in the third column. For example, then Colorado would be paying 37% more for power once this is completely implemented. Over 10 years, the cost will be $11.8 billion. And then the last three columns give us annual snapshots of the effect of these on employment and gross wages and real disposable income that we obtain by running them through our own computer model. And we are quite confident that this model is conservatively built, that it's calibrated in a sensible way, and we think these are reasonable estimates of the negative effects. So there you are. I did make it, thanks to Joe's generosity. So we have, majority of states have green policies. The Cape Wind is the mother of all boondoggles in terms of a green energy project, and yet may go through. It has increased electric rates for particularly for manufacturers. NSTAR has shown in Massachusetts how you can get renewable power at a far lower cost. And we see the costs of the Massachusetts mandates over 10 years, and we have looked at some of the negative effects on economic indicators of RPS standards through the country. This has been kind of a hodgepodge of stuff that we've done at the state level. This is easy economics. You know, it's hard, again, to predict the employment effects of a stimulus package, but it's easy to show that state-level green energy initiatives are a waste of money. Thank you.